In this paper, we address the challenge of scaling participatory design and the challenge of creating real societal impact through our research. Several studies address large-scale participation and sustaining initiatives, but there are few examples of how to do this in practice, and little is known about what happens when PD outcomes reach the level of national policy. So we have two general questions that we address in the paper. How can PD scale and can PD outcomes transfer between contexts? And how is PD equipped to create impact through policy? So our research contributes to ongoing PD discourses about the nature of PD results, how they are sustained, scaled, and how PD may create lasting impact on society. The takeaway in this case is that while knowledge generated in a PD project can travel to the level of national policy, significant challenges emerge when outcomes from a bottom-up PD is used in top-down policy. The paper reports from a case in which the outcome of PD projects was used to launch a new mandatory course called Technology Comprehension in Danish primary and secondary education. The course is presently taught in 43 schools in Denmark, with the prospect of becoming a national initiative after the pilot tests in 2021. It was influenced by the idea of computational empowerment, which emerged from the Danish Fab Lab at School project, which we've also published about previously, and the PD ideas of empowerment, democracy, and a critical stance to technology in our research approach. So these values, we argue, can be traced in the four competence areas in the curricula, which you see to the right, which some of us took part in formulating: computational empowerment, digital design and design processes, computational thinking and technological knowledge and skills, and also in the focus of the Danish Ministry of Education on the left that mandated the national initiative. So the case provides an opportunity to study what happens when outcomes of a PD project are transformed to national policy and are adopted by people who did not take part in the PD activities. We studied the Technology Comprehension initiative through 12 semi-structured interviews with individuals of different kind involved in the development and implementation of the course. We aim to recruit participants from a diversity of roles within education, government, and geographical areas. But none of the interviewees had directly been involved in the development of the curricula, except for the Minister of Education and the head of education and IT at government level, who commissioned the Technology Comprehension initiative. The analysis of the interviews resulted in three main themes: democracy and citizenship, technology and learning, and the question of sustainable scale. The first theme of democracy and citizenship arose when we asked why technology comprehension could be considered relevant. Almost all interviewees pointed to the ubiquity of digital technology and argued that understanding these were crucial for democratic processes. As school principal said, children today grow up in a society where you cannot relate to the digital. It's ubiquitous, and therefore we have to enable them to navigate in a society where digital technology are so dominant. The second theme that emerged was that of technology and learning. The theme arose when interviewees were asked about their understanding of what technology comprehension was about and how they envisioned it to relate to existing subjects and teaching practices. They all agreed that the four competences were important and were interrelated, but there were tensions between humanistic and STEM teachers, which reflected in which elements were expected to be the most prevalent in the actual teaching practices. As one teacher said, so you can see there has been a power struggle between those who would like to pull the course in the direction of computational empowerment and those who want to draw it in the direction of design. The third theme that emerged was that of scaling and sustaining technology comprehension within schools. This issue concerned whether sufficient resources and competencies would be available, and also concerns for long-time commitment were raised. As one teacher at a college said, it really demands political tailwind, and sometimes it feels like politics happen based on a few headlines and values rather than knowledge about what really makes a difference. So what are the implications for participatory design? Judged by this case, it is possible to make PD scale. The interviewees didn't know the field or subject of PD, but still their understanding of technology comprehension aligns with PD values and aims through the translation of PD into the curriculum. In their understanding, technology comprehension provides skills for critical engagement with technology and is needed for empowerment and democracy. The challenge of scaling in this case concerns fitting the new subject into an already full curriculum, upgrading teachers' competences with technology and design processes, and finally the question of infrastructuring at this scale. Usually participants learn PD through participation bottom up, where in this case the learning process is top down, from the curricula of the subject of technology comprehension to teachers, and from teachers to the pupils. This implies multiple translations out of hand of the PD researchers, and we do not yet know the results of this, even if our initial impressions might be positive. What we and PD could do from here is to investigate further how PD knowledge, practices, and activities may travel or scale efficiently through top-down processes, in addition to our usual bottom-up approaches. This also involves the question of how PD can engage in top-down policy making without losing the aims of democracy, empowerment, and quality. Thank you very much for listening.